5.4, side, 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 triangle congruence. So basically the theorem says we've got through side, angle, side, angle. We talked about CP, CTC. This one is called side, side, side because it takes three sides of one triangle to be congruent to the other three sides of another triangle, okay, for this to work. So basically, again, you have your tent. Jim's over here with his tent. Jim. All right, and you basically realize, hey, my side over here of my tent or my triangle is the same as the side over here with Jim's triangle or tent, okay? Then you realize, hey, this side is the same as Jim's side over here. Then you realize the base of your tent or triangle is the same as Jim's triangle over here or tent, okay? Therefore, these guys, these triangles or tents, okay, are congruent. And again, I'm using tents as metaphors. These are actually triangles, okay, even though they're terrible drawings, I know. All right, justifying side, 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 triangle congruence. So here's our first example. They say to use rigid motions and the converse of perpendicular bisector theorem. And I'm going to go ahead and do that to explain that transformations or transformational thinking is still being applied in geometry, okay, especially in proofs. So if you notice, triangle ABC here reflects across AC. Okay, that's actually where the reflexive property comes from for AC. So, for example, AC is definitely going to be congruent to itself, and that's the reflexive property. And that's something very important to notice. And it literally reflects. So knowing the idea of a reflection that occurs, okay, and that's my harping onto the idea of rigid motions. Okay, we had a reflection, okay, across AC. And if we did that, the distance from AC to B is going to be the same distance as AC to D. Okay, so they basically, those two triangles also have the same height in essence, all right? So if you look at it, and let me try to go ahead and create this whole proof since that is so important for you guys, okay? So again, we got our statements, and then we have our reasoning, right? All right, so first things first, they went ahead and said use rigid motions. I want to go ahead and say, well, we got AC being congruent to itself, and that's the reflexive property, okay, which stems from the idea of reflecting over a certain line. And if we do that also, A stays on that line because it's on the line of reflection in the first place, so it stays nice and neat right there still. And C is just becomes C prime, and B does become D, okay? So it does reflect across. So if we reflect, this length here is going to be the same as this length. So we have a side there, we have a side there, okay? AC is itself, so that's a side here, okay? And then CD should be the same side as BC, okay? Because reflections do preserve rigid motion. So, so we had AC, that's a side. Step 2, we can say AB is congruent to AD, and that's because reflections, reflections preserve rigid motion. And then step 3, and again, that was our second side. And our last step, or third step, is basically BC is going to be congruent to CD, And for the same reason, reflections preserve rigid motion. Now, basically, you just got three sides, so we can say finally at last, triangle ABC is going to be congruent to the other triangle, triangle ADC, by the side, side, side triangle congruency theorem. All right. So example 2, we're still proving triangle congruency with side, side, side. If you look here at our image, they actually give us some values, okay? Well, we know that AB, the smallest side of the triangle, is the same as DE, which is also the smallest side. So we got a side here that works, okay? And then we have a 2.3 right here for AC, as we do here with DF. So there's our second sides, our second pair of sides that are congruent. And then lastly, we have three sides that are proven to be congruent. Okay, so yeah, these guys are definitely congruent. Awesome. All right, let's prove these ones. Let's see. We have 12 centimeters here for our small guys. That's a pair of sides right there that are the same. We got a 24. It seems to be the longest, right? That are the same. All right. Now all we need is our second pair of congruent sides, which they are both 20 centimeters. So yeah, these guys are definitely congruent. All right, here's number 1. Prove that these two triangles are congruent, or explain why they are not congruent. Okay, so try to match up what side can match up with what. All right, which side is going to be congruent to the other side, all right, to its corresponding side. All right, your turn number 2. Prove that the triangles are congruent or explain why they are not. Now, they didn't give you numbers, so this is more of a proof idea. So try to create a proof, all right? What did they give you? Yeah, they gave you some tally marks, sure, but you only got 2 sets of tally marks, so tally me bananas. What can you find to figure out your third side? All right, applying triangle congruency, example 4. Find the value of x for which you can show the triangles are congruent. So if we look at our objects here, we are assuming that these guys are congruent, these two triangles, and they are looks like to be isosceles triangles. Iso means 2, which means there's 2 sides that are the same, and we know that the bases here, even though one tents upside down, the bases should be the same. So if BC needs to be congruent to KL, okay, because again, that's because of CPCTC. BC again is 4x minus 6, which should be equal to KL, which is 3x minus 4. We're going to use a subtraction property because again, I'm just wanting to isolate the x. Get rid of the negative 6 with a plus 6. What you do to one side, do to the other. So 4x minus 3x is 1x, and negative 4 plus 6 is 2. They just want us to find the value, so there's our value for x. X equals 2. And if you plug it back in, they should be the same, okay, for the centimeters. All right, your turn number 3. Go ahead and find the value for x, okay? So who can he match up with? And then set them equal to each other and solve for x. Thank you, guys. Have a great night, and if you have any questions, let me know.